Welcome to my coding channel, Coding Learner. In the previous video, we learned about how we are search an element in our array through the linear search or a binary search. So, in the binary search, we need that the array should be in the form of sorted. So, in this video, we learn how we make the array in the sorted form. We having a different methods like bubble sort, insertion sort, quick sort, merge sort. So, first we learn about in the bubble sort, we having a outer loop for the pass, and the pass will be goes from 1 to n minus 1. Here n is the number of the element present in our array, and inside our pass loop there is a one loop as well with iterates the element of our array. So I indicates the index of the array. If the I is equals to 0, then we are pointing to the zeroth index element in our array, and we need to compare the ith index with I plus 1 index, and here 12 and 45 are the elements which are need to be compared. If the ith element is greater than our I plus 1 element, we need to swap these elements, but here I ith element is smaller than our I plus 1 element. Now we move forward for the index number 1, and here the pointer is 45 and our I plus 1 is 23, and when we compare that, we find that 23 is smaller than our 45, so we need to swap these values, and in the second iteration, or the I is equals to 2, we are indexed at second, and we are comparing two values. So 45 and 50. 45 is smaller than 50, so we don't need to swap these values. We have to move forward for our I is equals to 3, and our pointer is here. 50 is greater than 18, then we need to swap this, and in the I plus I is equals to 4, our pointer will be at this position, the fourth index of the array, and we are comparing the fourth index element with our fifth index element. We find that 6 is smaller than 50, so we need to swap this, and we found that the greatest element in our array are placed at the right position. Before the 50, all the elements are smaller than our 50. So it means that in every pass, one element will be placed at their correct position. So that's why we are iterate the ith loop with n minus pass. So the I will be started to 0 and goes till I minus, and I is equals to n minus pass. So now we have to move for the second pass, and our ith iteration will goes from I is equals to 0 to I is equals to number of the element minus the pass number, and here element is 6 and the pass will be second, and it iterates 4 times. It means that the iteration will be 0 to 3. So in our I is equals to 0th index, we are comparing these two elements. We find that they are in the correct position. Didn't need to swap these values because 12 is smaller than 23. Now we move forward for I is equals to 1, and we are comparing these two elements, I and the I plus 1 element. So we find that the ith element is smaller than I plus 1, element. Now we have to move forward for the I is equals to 2, and we are at this position and we are comparing 45 with 18, and we find that in our array. So we need to set these values. That's why I put here star. And in the second iteration and in the third iteration, the index will be 3, and we are comparing the fourth index with 3 in third index. We find that ith index is great ith index element is greater than a I plus 1 index element. Thus we need to swipe these values, and we find that of our index loop, we find that two elements are placed at their correct position, and before 45 all the elements are smaller than 45 and 50. So now we move for the third pass, and in the third pass the index loop will goes from n minus pass. It means that the index will goes from 0 to 2. Now in the I is equals to 1, we are having ith element 12 and the I plus 1 element is 23. When we compare that, the 12 is smaller than 23, so we don't need to swap these values. We have to move forward for the I is equals to 1, and here I is equals to 1 is 23 and I plus 1 is 18. When we compare these elements, we found that our 23 is greater than our 18. Thus we need to swap these values, and in this I is equals to 2, we are at this index, the second index of the array, and we are comparing the second index of the array with third index of an array. We find that our ith index is greater than our I plus 1 index, so we need to swap these values. And after that we found that three greatest elements are placed in their correct position. Before these elements, all the elements are smaller than our three elements. Now we are move forward for the past fourth, and in the past 4 we are need to iterate our index loop with 0 to 1. It means that we are comparing first two element, because the I is equals to 0 and our I plus 1 is the first index element. We find that our 12 is smaller than 18, so we don't need to put or swap the elements. We need to move forward for I is equals to 1, and here I is equals to 1, the first index element is 18 and our second element is 6. When we comparing these, we find that the ith index element is greater than our I plus 1 index element. We need to swap these, and we find that our four elements are placed in their correct position. Before these elements, all the elements are smaller than our four elements. Now we move forward. So in the fifth pass, the index loop will be goes from I is equals to 0 to I is equals to 1. It means that we are need to traverse our index loop just one time, and we are comparing the I zeroth element with our first element. We find that our first element is smaller than our zeroth element. Then we need to swap the values, and after that we find that all the elements are placed in their correct position in our ascending order form. So that's it about the bubble sort. Now we move forward for the implementation of the bubble sort. So that's it. Me to English. So I created a int type array with size 10, and these are the elements of the array. Let's take 6 elements. So we are creating the int pass, which is the outer loop. I initialize the pass with 1, and there is a while loop which goes pass will be always smaller than our array size 6. So inside our while loop we having a outer in our loop for iteration every element in our array, which goes from I is equals to 0 till I is smaller than I minus pass. Then I is incremented every time. Let's define int and will be 6, the size of an array. So we are also taking as size of array element divided by size of the array 0, and it calculates the size of a array, the number of the element present in an array. We are dividing the whole size of an array with a one element. So we know that if the array contains 6 elements, then we need to multiply the 4 number, because each integer contains the 4 byte in the memory. So then here 24 is the total size of an array, and we are dividing the first element size, which always be a 4 because it is an integer. Then we found that 6 is the number of the array, number of the element present in our array. So this is how we calculate the size of an array. So inside our loop we comparing the array ith index with array I plus 1. So if the ith index is greater than our I plus 1 index, we need to swap these values. We take the int temp variable which store the array I element, and in the array I element contains the array I plus 1 element, and here array I plus 1 element will be our temp. So what is happening here? If our I is equals to 21 and I plus 1 is equals to 6, so the 21 will be stored in the temp, and array I plus I index store the value of I plus 1 index, and here the array I I plus 1 index is 21. So now after traverse all these lines, we find that our array I index will be 6 and our array I plus 1 index will be 21. So this is what happening here. So after the swapping, after the for loop, we need to increment in our pass so that it runs only 5 times. So after this bubble sort function, we having a for loop to display our array, which is now in the form of sorted. Let's take smaller than n, and I will be increment every time. And we having our statement out array ith element. Let's take some space. So that's it. So that's it. Let's run. Okay, we are getting the array in the sorted form because of the bubble sort. So I think bubble sort is the simplest sort, and insertion is also simple, but it has a high complexity because in each pass we have to iterate the elements. But it is when we compare the bubble sort with the remaining sorts, we found that the bubble sort has a high time complexity, so it is not used when we are need to take care this time and space complexity. So that's it. In the next video we do the insertion or selection sort. So that's it. For more shorts and videos, please like, share and subscribe.